everyone. Before we program the left rectangular approximation method in Python, let's go over the steps carefully and completely in general so that we'll know what the algorithm is supposed to be. If you're not used to making algorithms, this is a helpful technique. It's to do it yourself and then notice what steps you're doing, because that's what you want to tell the computer to do. So, let's pretend we have some arbitrary function f, and we're going to find the area under the curve from a to b. And let's use n as our variable for the number of rectangles, the number of subintervals. So in this case, it looks like n is 6. All right. Well, if I'm going to find the area of each of these rectangles, I need to know the height and width of each rectangle. Well, the width is easy. The width of each rectangle, which I'll call delta x, the width of each rectangle is always the same. It's the length of this entire interval, b minus a, divided by n, which is the number of subintervals. All right, well, so that was easy enough. Okay, but what's the height of each one? In order to calculate that, I need to know what are all of these x-coordinates, x1, x2, x3, and so on. And then if I know what each one is, I can evaluate the function at that point. So, for example, the area of this rectangle would be the height evaluated at x0 times that delta x, times that width. And then to that, I would add the area of this rectangle, which is f of x sub 1 times delta x, and so on. This would be f of x sub 2 times delta x. So that's the idea. When we program this, we don't want to try and write out a single equation for the entire calculation, because the whole point of this is when we write the program, we don't know what n somebody's going to choose. Maybe n will be 100. So that's the first reason. And the second reason is we wouldn't want to type out 100 different terms. So instead what we're going to do is we're going to use a loop, and each time the loop runs, it's going to calculate the next term in our sum. So the first time through the loop, we'll calculate this term, and the next time through the loop, we'll calculate this term, and we'll add each term into an ongoing sum one at a time. So the last piece that we need is we need a way of figuring out what is this x0, x1, x2, x3. Well, x0 is the same thing as a, so that's easy enough. And then to find the next one from the previous one, we just add in a delta x, because every time we move over a rectangle, we're moving over by exactly delta x. So it's like whatever our previous x sub I was, the way you get to x sub I plus 1 is it's equal to the previous x plus a delta x. So that's the kind of update rule we're going to use inside the loop to move one rectangle at a time. Okay, let's try it in Python. So here we are. I'm going to start coding. We'll use Python. Let's start the way that we always do by defining a function. So I'm going to define a function of x that will be x squared. Okay, and let's just make sure it works. I'll print f of 2. This should be 4. Great. All right, well, let's create the variables that we want first. So we're going to have our a. I'm going to set it to 1. B, I'll set it to 6. N, I'll set it to 6. All right. So I said before that we wanted to include the width of each rectangle. So let's go ahead, and we have enough information right now to calculate that. So let's go ahead and calculate that variable as well. So I'm going to call it width, and it's going to be b minus a divided by n. Okay, so now I want to create a loop, and the number of times it should loop is the same as the number of rectangles. So if you remember how we loop, we say for val in range, and then I want it to go from 1 up to n, whatever n is. So that'll loop n times. And if we wanted to, let's just go ahead and let's print width that many times. So I'm hoping that this is going to print, let's see, 1, 2, 3, 4, 5. Okay, so it seems like we maybe didn't, right? We forgot that when it loops, it doesn't actually include this last number. So it's going to go 1 up to a number that's 1 less than n. So let's make this n plus 1. Okay, so now it's looping the right number of times. 1, 2, 3, 4, 5, 6. Great. And this is, in fact, 5 divided by 6, 5/6, which is exactly the width of our rectangles. Great, so far so good. So I'm going to create a variable called sum that starts at 0. And the idea is every single time through this loop, I'm going to add the next term into this ongoing sum. So, for example, if I wanted to just say sum equals sum plus val, this is going to add 1 plus 2 plus 3 plus 4 and so on up to, but not including this number. So it's going to add 1 to n. Oops, except I'm not displaying anything. So let's go ahead and print sum. So you see, we've got 1, and then here we added 2, and then we added 3, and then we added 4, and then we added 5, and then we added 6. So that's the kind of thing we want to do, except instead of adding val, we want to add whatever the next term is for our rectangle area. So before we do that, now we've got to figure out what is that term equal to. Well, I know it's equal to the width times the height of my rectangle. Okay, but what is the height of the rectangle? That's another thing we've got to figure out. So if we look back here, the height of the rectangle is going to be our function evaluated at whatever x value we're at right now. So let's create a special x value that starts at a. So it's going to start, sorry, I'm used to programming in Java, and in Java you have semicolons. All right, so we're going to start our x at a, which is the left-handmost point. And we're going to say height equals f evaluated at x. And then after we've done that, well, let's do it after the term. So even after we've added the next term into the sum, before we do the next loop, we've got to take our current x value and we've got to add the width to it, because that's what's going to take us to the next x value for the next rectangle. Okay, I think this is probably going to do it. So let's print the overall sum now. Okay, well this isn't very helpful because I don't know what the right answer here is supposed to be. So let's try and evaluate a function where we do know the right answer. So let's pretend the function is, let's maybe make it 2 times x. And we're going to go and find the area from 0 to 10. If you think about what this graph looks like, it's just going to be a big triangle whose width is 10 and whose height is 20. So I know that the area is going to be 1/2 of 10 times 20, which is 100. So we should get something close to 100. We're getting 83, which is not that close, but we only have 6 subintervals. So let's make it 60 subintervals and see what we get. 98, that's getting closer. 600 subintervals. 99, getting closer. 6,000 subintervals. 99.9. Let's just add a bunch more zeros. Cool. So it definitely seems like this area is approaching 100, which is what we expect it to be. So congratulations, you have found LRAM. The rest of your homework is to modify this code so that it will evaluate the area using RRAM and then MRAM.